Coding session time. Yeah, so last time in the Bangalang series, we got our certs working, which I think is pretty sweet. I think this is going to be super helpful because over time I've just been getting less and less confident that all of this stuff that I feel like frantically throwing together and not really confirming. Yeah, my confidence and all that has been getting lower and lower. So I really like to do like a suite of tests, and that's what having this assert will facilitate. So I think today we're going to go on a bit of a bug hunt. We're going to create a whole bunch of assertions, testing all sorts of different features in the language, and I'm sure we're going to come across some bugs that we can then fix up. So the way I want to do it is I want to have like a test file, right? Yeah, which does lots of things and asserts them. And I want the compiler to compile and execute that every time, like in the background before the main program, every time. So every time we run the compiler, we're running the suite of tests. I think, while we're just very actively developing and it's just me, I think it's a good approach. So let's see if we can set that up. So in our main, before we run, I want to run a test suite. Which I'll put down the bottom here. And essentially it's this kind of similar to run, but run exits with the exit code afterwards, and we don't want to do that. In this case, I guess it's more like something like this, right? When we run NASM, we check the exit code and we exit if it was non-zero. That's basically what we want to do here. I guess here we need to do build exec. So we go like tests code. Failed tests. Something like that. And the source path, I'm gonna put it in the source folder. A little bit weird, but tests.bang. And then the output can just be like, I don't know, bin tests, whatever. Ideally, we would not really output files. Well, I guess we do need to run something. So anyway, I think that's pretty much it, right? We build a test.bang file, we execute it, and then we just verify that it came back with a 0 exit code. So in here, we're going to need a new file, which is test.bang. And actually, the first thing I want to put in here, I want to steal from here, is this comment stuff. And let's do a single line comment as well. Just so as part of the test suite, we verify that all the comments are working fine. Because if nested comments are not working, all of this is invalid code. So we should get an error. Well, I guess actually, technically this is valid code. So maybe I'll just go like this, because on its own, a string is not valid. And this should still be all we need, because it should treat this as a string and therefore ignore this. So if I run, so this is the output of this main program, which I might just take the assert out of. And let's take this comment out as well, because we'll put it in the tests now. But yeah, I wanted to take that assert out so that yeah, we get a nice exit code of 64, which is this here. So then if we see any errors, it should be because we've introduced them in our tests here. And now we can make some tests. I think the easiest to start with is sort of like assignments, declarations, and then we can get into some expressions, and then kind of like procedure calls, passing different things, returning different things. I feel like those are the main things to check. I guess also around, if, for, scopes, yeah. There's quite a few things we can check. So let's start with doing some declarations. I guess we need to steal the assert. I don't know if we need it in here anymore, but we need to bring it up and put it into tests. We don't have, because we don't have any concept of like libraries at the moment. So we just need to have it in the same file, this assert procedure. So B2 should equal true. I'm just going to say like test declare declaration from Boolean. And then I want to do like B1 and assign it from B0. And that should also be true, but now we're assigning from says assigning from bool, and it's like assigned from bool var. Just to differentiate, because it's like number var, because we'll do like the same thing but with I8, and we'll say like 1 1 1, but that should be, I guess, I. So that's Booleans and integer declarations. Let's just make sure that's all good. Yep. What else can we declare? We can declare, well, it's an identifier with a certain type, and the type can be a pointer, it can be an array, or it can be both. So let's try an array. So A0. We can't just compare A0, so we're going to have to do like an index of it. So if we say that that's like 42, that should be correct. This should not, this should fail. It's not really from, so it's not really from, it's like declaration of array. I'm just curious what happens with this. Unsupported operation size. This should give an error, but it should give a better error than that. That's not a nice error. I'm not so happy with that. Also, I've been thinking about this for a while. Let's do this. All of these bug print lines, really they should be asserts. These are things that should never happen. If they happen, it's because there is a bug in my compiler. So really it feels like an assertion to me. So where else are there bugs? In generation. Failed to generate assignment. I'm not going to give much context with these things. Yeah, because like I say, it's not something that's going to the end user. This one cannot move to immediate. I feel like this cannot copy to immediate. And here we can just put this in here and invert it. So we're saying the destination cannot be an immediate. And I kind of feel like that should be at the top. So yeah, I'm just doing some sanity checks at the start of the procedure. This one again is just false. By putting false in here, you're saying that the assertion is always going to trigger. So it's basically saying you should never go here. This should never happen. Unsupported register size, unsupported operand, unsupported operation size, and we have errors. Oh, lots of errors. I guess because we're not returning, we need to return something, a location. I'm just going to return empty. Like I say, we should never go here, so I'm just going to return an uninitialized object. Is it happy with that? Yeah. This is the same. Unsupported operand. So I'm just going to return an empty string. And maybe this is the same down here. Operation size. Yeah. Is there another one? No, that was the last one. Okay. So now we should get, yeah, runtime assertion, unsupported operation size, but that's not the error that we want. We want a better error. So these are our tests. That's right, it was this. I forgot even what we were dealing with. So these two should have different types. This should be a number and this should be an array of 10 integers, and they should not be compatible. So let's comment out all this stuff. So this is the first line in the program, and it is a declaration, and type checking is what should take care of it. Type check declaration. So let's check this. Okay, left-hand side node, making sure that it does not exist yet. The name, good. We also have a right-hand side node. So left-hand side node has a data type of 10 I8s. Yeah, so it's an array of I8, good. The right-hand side node does not have a data type. Let's step in, step over here. So that should have added a data type. So now the data type is a number. Then when we coerce them, the resulting data type is array of I8. So it's coerced number to I8 array, which it should not. So I guess it's gone into one of these, right? It's seen that one is number and one is I8, and it's ignored the fact that the lengths are different. We know they're not the same. These are like empty data types. We're not dealing with that. We know they're not the same. And we know that the names are the same, but nowhere do we check that the lengths are the same. I think what I had in my mind here was that if we know that they're not the same, but the names are the same, that means that something else was different and we should quit out. And then in my head, I was also thinking, okay, so now we know that it's only the names that are different, which is totally not true. So maybe it's like if they're different. No, I think what we need to do is like just individually check these things before we get too confused. If the links are different, that's a no-go. If one's a reference and one's not, it's a no-go. And if the names are different, I think that's what we do here. If the names are different, then we check whether it's something where a number can be upgraded to something else, because that's fine. And then I think we just continue. There's nothing to do otherwise. So I don't think we actually need this check anymore. So I think that is... Okay, yeah, now we get incompatible types. Line 23, column 14. Interesting that it's giving that as the location. But close enough for now. Maybe one day we can improve it. So now I need to take this off. Okay. Now that I've fixed the type, made the type checking better, it's exposed more issues. Oh, line 81? That must be in here. Okay. This, yeah, I knew that there's some issues around this code, and I think I know what we need to do. At the moment, it's in generation. And generation. Here, we do like auto dereferencing and generation. For primaries, which are part of expressions, we do that. But here, this is, sorry, it's not, this is column 21, so it's this one. So here, it's not really giving the right type information. It seems to think that this is still a pointer, even though it's been auto dereferenced. See, it's calling it a pointer to an int, not just an int. Because this is a pointer to an array. Then we do an auto dereference, which makes it just an array. Then we do an index, which makes it just an int. So that's what the type checker should see. It should see just an int here and a number here, not a pointer to an int and a number. And what I want to do, I think, is if we go back to our AST tree, I kind of want to model this out. This is all pretty like old stuff. Where are we? So let's try and model this. It's an assignment. It has this on the left and this on the right. So this is an assignment. Let's just commandeer this. I think I'm just going to strip this out completely. And they do both have identifiers, the left and the right, but there's going to be a bit more to it. So the left-hand side is an identifier, but it's an identifier, but there's also an index going on, which we have a separate node for. But there's also an auto dereference going on, which we don't have a separate node for, and I want to add a node. So essentially, I want to end up with a stack of 3 nodes, identifier at the bottom, dereference, and index. So then when we evaluate this, I'm going to have identifier, so that's the pointer to the array. Then we're going to dereference, which is going to take us to the array. Then we're going to index, which is going to take us to the single int, which we can then put will be assigned to. We're assigning to that single int. And then on the right here, actually it's not an identifier yet. It is an add, I think it was. Yeah, it's an add. And the left-hand side is exactly the same as this. The right-hand side is just a number. So we've got an add. Damn it. We have a number over here. And then on the left-hand side, we have this again. So this is our full structure that I want to have. And then through this structure, we should have the correct type information at here for the add. Right? Like I said, this is a pointer to an array, just an array and a single element. And the single element of the array can be added with a number, and that's fine. And then the single number of the array can also be assigned to with the result of this add. So I want to construct this structure. And then in the generation, right, the idea is that if we have that structure, because there's already this dereference code here. So if the structure is correct, we don't need the dereference stuff in here. Can just cut that out. And I guess I can put this here like that. So that's nice, and that becomes nice and easy, right? Each case just has one job to do because we structured the AST correctly. And I'm hoping I can reuse this code for the left-hand side as well for the variable, but we'll get to that. So the first thing is parsing. I think that's where we start. When we parse our primary, we do have here, this is when we're indexing into the primary. It'll be an identifier, followed by, because this switch is the first thing, and then followed by opening square brackets. So followed by indexing. And what we do is we essentially wrap the node with an index node. And we can't add the dereference node here because the parser is stupid and it doesn't know what it's referring to. It doesn't know what the identifier is referring to. It doesn't know that it's an array. It doesn't know that it's a pointer. It just knows it needs to index because it sees a square bracket. That's it. So I think, yeah, here's parse variable. And parse variable, I think we essentially want to do the same thing. We did have an identifier node, which we just put the index on directly. But now I want to wrap that in an index node instead. So now what we have is closer to the structure. We don't have the dereference node yet, but we do have the index nodes. So we need to go to type checking to add the dereference nodes because that's where it knows about the type. It knows whether dereferencing is needed. So when we type check the primary and we get to index, so node children 1 will be the identifier and node is the index. So after we've type checked this, we know the type of this guy. And if the type of that guy is a reference, and we're trying to index into that reference, we want to insert a node here. Maybe I can copy this code. Which adds a, well, not adds a dereference node. Do we have an example? Dereference. Okay, this is where we add a dereference node. So we'll just do the same thing as that. yeah, we want to wrap it in a dereference node. So I guess we want to say that this is the child node and reassign that to that. And then we add the child node as a child of the dereference. So this is the index. This is the dereference. And then the first child in here is the original first child, which was the identifier. So that's our stack created. The other thing we need to do is propagate the type information. So the data type of this should be the child node's data type, but here we want to say it's not a reference. We take off the reference information. And then when we continue along and we do this, this will give us the type information from the dereference node and put it into the index node, and then say the length is 1 because because once you index into something, the result is a length 1. It's just a single element. So this is either going to reference the dereference node if it auto-dereferenced, or it's going to reference, this is the identifier node. It's going to be one of those, but either of those should have the correct length of the array, so I think this should be fine. But this should be the identifier itself, so we can't refer to that like that. I think the easiest thing might be just to save the identifier here, and then just refer to the identifier. So I think that should be wrapped in a dereference node now, if it's required. And now we need to do the same thing for variable. Here's type check variable. So previously type check variable had assumed that there's just one node, the identifier node. Now it could potentially be an index node wrapping that node. So we need to extract the identifier node. If the node we are given is an index node, that means we need to get the child, and that will be the identifier. Otherwise, we're already looking at the identifier node, and that needs to be a pointer. Now we can go like this. Because the index node is not going to have the variable name in it. Only the identifier node has that. So we just need to do that. I think then we can just go like identifier node.data type comes from the variable. And now this stuff here, because we were using this -1 to determine whether we're indexing or not, but now we have the index node to know that. I think this is the only place where we actually used that. So I think back in parsing, we have like this parse identifier where we defaulted it to -1. So I think we just put that to 0. So then this is not needed anymore. And this branch here is basically saying if we were indexing. And to know if we're indexing or not is just this, right? We also need to take the data type from the identifier node first, and then do the length. I guess this is identifier node. And identifier node value. Okay, so now we need to add our auto dereferencing stuff in here. So if we find that the identifier node is identifying a pointer, then we want to do this auto dereferencing. So if the identifier node data type is a reference, we want to take a copy of it. So identifier node is a pointer, so I want an actual copy. So that becomes a dereference. We take the type information. Yeah, I think this is all good. I do think, because this is a pointer, and we're, see, like it's potentially a pointer to this, and here we're reassigning that. So now if we try to use identifier node, we're going to be pointing at this. So I wonder if I can take that. Maybe I'll just like explicitly say, hey, we've got a copy. And then I think just to be safe, I'm just going to use the copy everywhere. And we're not assigning to it anywhere, are we? We don't modify it after that. There it is again. No, I think we just query it. So I think that should be safe. So now we have like the correct structure. We've inserted these dereference nodes. Well, that's the intention of the changes I made. So I think we have this correct structure. We did change the generation here, so this should be fine. And if I'm right, we might be able to just reuse this code, because the variable for assignment, the variable on the left, is kind of a subset of the primary from our expression. So the variable can be an identifier optionally followed by indexing, and the primary can be a primary optionally followed by indexing or other things. There's a few things going on. And then that primary can resolve to identifier. So primary is a lot more flexible, but it's like a superset. You know, variable is a subset. So as long as this generate primary does what we want for the variable, it should be all right. And the only concern I have is if we use generate primary to resolve this, and it returns us some copy of the original variable. It doesn't actually return this, it returns like a copy of it, and then we assign to the copy, then we're not actually assigning to this. It's not helpful. I don't think it does that, but I just want to make sure. So it's like identifier, dereference, and index we're concerned with. Identifier, it does do a copy, but it's like, you know, it finds where the variable is on the stack, and then it copies that address into another register. And the only reason it does that is because the stack pointer might move. And if it does that, we don't want our identifier to be invalidated, right? If we're relying on an offset from the stack pointer and then the stack pointer moves, we're going to be looking at the wrong place. So it takes a copy of that, the stack pointer, basically, with an offset. So I think that's good. Even though it takes a copy, it's like it's still giving us an address to the original variable. Dereference can also do a copy, but again, with good reason. Because if the original variable is a pointer, then the dereference is going to, instead of giving us the pointer, give us the thing that it's pointing to. which is good. And index looks like it just adds an offset, which makes total sense. So I think this is going to be fine. Generate primary to use in, I guess it's an assignment. So we want to use this somewhere. Let's just figure out what the hell we want to do with it. I guess it is for the left-hand side, which feels weird, but we want to generate a primary for the left-hand side. What do we need to pass in here? File, I guess this is a pointer. Context and register number, which I guess we just put 8. I mean, oh. Oh, I thought it was a, okay, so it doesn't take a pointer. Really? Huh. Generate primary doesn't take a pointer. I thought generally everything took pointers. Oh no, I think I'm probably thinking of like type checking and stuff. It takes pointers because it modifies things. But we're not modifying the nodes here. So yeah, that's fine. Yes, we pass in a register number because that's how generate primary works. But in our case, it should never actually copy. Oh no, it might copy to that register because we might end up following a pointer or something like that. Okay. So I guess this is LHS location. So I guess a lot of this was, yeah, this was like this is stuff that generate primary takes care of. So I think this has totally resolved the left-hand side. So the right-hand side is what we're interested in generating the expression for and putting the result so I guess that's like the destination. Okay. So I think that like replaces all of that code. I'm really curious to see if this works because it just, I didn't like that code. I think it was a mess and didn't really work properly. So hopefully just using generate primary, this looks too simple almost. We generate the primary, so that should give us the address of our left-hand side. Then we generate the expression on the right-hand side and put it in that address. I mean, it sounds right. So let's see what happens. Index 2 out of bounds of A0. Okay. Index 2 is out of bounds. Let's type check variable. Let's have a look, shall we? So identify node copy data index 0. Well, a node has the data index of 2, yeah. And this has a data type. Oh, it doesn't have any data type. Okay. Well, that's a problem. Okay. I think it's because we have used the wrong node here. We were using the index node, which does not have the name of the variable, so it couldn't get the type information. Oh dear. Well, that's not better. Not particularly better. Oh dear. Okay. So let's have a look at the assembly. We have a lot of assembly. So maybe I can just like cut out the stuff that's not relevant. So we have a declaration of 10 bytes. We have an assignment where we put, that's interesting. Yeah, we did some optimization a while back, and I feel like I keep adding instructions where they're not potentially not needed. Like in this case, I mean, we don't really need to do that, but whatever. Okay, whatever. So this looks right. You know, it looks like we're putting 42 into a 2-byte offset from the stack pointer, so that should be index 2 of the array. Looks good. Now when we do this assert, this should be allocating. Okay, well, I guess it's a call, so I guess we're allocating for these parameters and for the return. So I guess this is allocating the 2 parameters, maybe. Copying the stack pointer into R10, and then, yeah, I don't like how we have so much of this now. And then we're getting offset 4 from the stack pointer, which makes sense because we just added those 2 bytes to the stack pointer. So now R8 plus 2 becomes plus 4. Comparing it with 42, setting the result in R8B, moving that to the top of the stack. So we're putting that in there. Now we do another double allocate. We like double allocated this. We haven't done any cleanup. We're double allocating this parameter. And yeah, so now we're copying the string of information into there. And now we're saying, okay, let's put the string in the address of the string here. And now we're doing a copy. Okay, so at the end we do copy from here to RSP. But we never use that one, I feel like. Maybe that's kind of like for the result of the expression. I don't know. We need to have a close look at that at some point. So we've finished the expression. Now we're doing a 16-byte copy. This is probably the string that we just made here. We're probably copying it. Yeah. But it looks like a pointless copy. No, we did add to the stack. Okay, we deallocated. Yeah, so now we're going to there. We never deallocate this one, I think. I don't see a deallocate for that. All right, here's a deallocate 18. So we deallocate 16 and another 18. So that's those two 16s and those two. Okay, so everything gets deallocated. Just confusing, you know. Copy. So, well, I guess we could just make sure that it is this line that's causing the issue. Yeah, it is. I assume it's the assert line. No, even without the assert line. So if I go like this, what's going on? Is it not part of the, is it not actually the tests that are failing? Is it this example program? Let's uncomment everything and let's comment out the main run. Okay. So I broke the main program. Okay, let's just leave this commented out for now, I think. And do some more tests, and hopefully when we do more tests, we'll resolve more things, and then maybe it fixes, I hope, the main program. So we have declaration of array. Let's say declaration of pointer. So a pointer to I8. I guess it can be like a pointer to I0. So because it's like P0. So this should fail actually, because one's a pointer, one's not. Invalid token at line 26, column 5. So it's not happy about that. Failed to pass statement. Failed to pass statement. Here's statement. Let's check where it goes. So it seems to think that it's the first token. We do a declaration, it sees these three, and then it just says, I'm done. I'm done. Find me a new statement. That's weird. So I guess we are already, let's try debugging it, eh? I guess we're parsing, I'll take these out, but we should be parsing a declaration. Colon data type. Colon data type. Doesn't have hat. So when we pass type. Yeah, see when we pass type, we're saying like the first one could be a hat. Let's deal with it. But up here in declaration, we don't account for that. We need to say, you know, if it's a hat, also do pass type. So I guess it was skipping over this, not seeing an equals, yeah, and just finishing the statement. Okay. Incompatible types. Oh yeah, I think that's legit. Yeah, that's what I was saying was legit here. So this is a pointer to an I8 and a 1 and a number. So this one I need to dereference. Okay, good. Declaration of pointer. So now I want to declare a pointer to an array. So PA. And that can be A0. No, pointer to A0. Declaration of pointer to array. So then this 2 should be 42. And this should test the auto dereferencing. Yeah, because this is not auto dereferencing. This is auto dereferencing. So we did all that work and we never were actually auto dereferencing until now. Here is an auto dereference. So it's happy with that. Declaration of pointer to array. Awesome. Okay, I think that's all of the declarations. So I think I kind of want to do like something very similar. Probably don't need to, but we do like assignments. So if I go B0 equals false, assignment from bool, then B0 should equal false. And if I say maybe we'll make it B1, and then B1 gets assigned back to B0, so that should be true again. I1 equals 2, so that should be 2. And then we assign it back from I0, so that should be 1 again. Now, if we say, we don't have 2 arrays, do we? So let's go like I1 and then A1, and then A1 equals A0. Hey, can we do this? I'm curious if that's going to be an error or not. And then if we go like P1 equals P0, then when you dereference P1, you should get 1 again. And there, yes, we just did that. So now PA1, I think, we want to test assignment, but these like P1, PA1, these are new variables, and A1. So I think, well, I want to check we get. So that's all happy. So you can do that. You can assign. So we've got like this declaration from number. So declaration of array, declaration of array, declaration from array. Let's do that test up here. So now we do have an A1. Yeah, so I guess we should sort of go A12 equals 43. So we change it. And then when we do this, it should change back. Yeah. Now this, because we want to do assignment, we don't have a P1 yet. This is a pointer to an I8, right? Then we can do that to test the assignment. And this is a pointer to an I8 10. And we should be able to do PA1 equals that. And then PA1. Whoa, okay. I kind of skipped through that without really understanding what I was doing. Let's comment these out. Okay. Let's try this one. Yeah. Let's try those 2 lines. It's happy with that. So this assert is not happy. Failed tests. So even if we get a segmentation fault or something, we still get failed tests. So, okay. I wonder if this is the issue that we saw in the main program. So PA1 is a pointer to an array and it's pointing to A0. And A0 is an array, so I mean that should be fine. So it should be like the last stuff down before the procedure call, or the procedures. So there's the assert, the exit print, our default exit. So this here is quite big. I think that is it. I'm immediately surprised by this. Okay, so it is printing that out all over the place. Call kernel. Yeah, because call should be only if, well, I guess they are, aren't they? I guess they are. Like it's this call here, yeah. The whole statement is a call. Yeah, all right, that makes sense. So this is the start of it, basically. This it was happy with. I think I've done something messed up, haven't I? I've done something messed up. What is this? Yeah. I think I've gotten a bit overzealous with my expression code. I think is a little bit overprotective. Load the effective address of that and then move it into that. Oh, Jesus. That's crazy. Okay. It's just crazy how much R8 has been used in there. Yeah, this looks like the code we were looking at before, right? I mean, I didn't see anything particularly wrong in it. So this is where we're doing an auto dereference of an array. And I think it's the first time. No, this is an auto dereference of an array also. So this line actually should be exactly the same as this line. So it must be something in here. It's I think something actually above in here. So it declares 8 bytes because it's a pointer and it needs 8 bytes. And then it does some roundabout weird shit to, so R8 is the address. R8 is the stack pointer. And then it's saying stack pointer plus 42, which I guess should be that previous pointer. And then it's moving R8 to, see, this looks wrong. That looks wrong. I think it's overusing R8, you know? I think it's overusing R8. And additionally, I think this is in our expression code. Where is it? That's our copy, so we're a bit low. Primary. Is it in primary? I think it's this kind of stuff. You know, we're being very careful, but because we're using register number, we're kind of reusing register number a bit too much. Because this becomes one of the operands as well as the destination. Yeah, it's being used as one of the left or right-hand side. I guess I'm interested to see how does it get two of these? Ah, left-hand side, right-hand side. It's an assignment, right? It's an assignment. Left-hand side, right-hand side. They're both using 8. So I'm going to do that. And here, I'm going to say 9. Because we're putting, I think we're figuring out the left-hand side stuff. We're putting it in register 8. And then we're figuring out all the right-hand side stuff. And we were also putting it in register 8. And I think that was like causing issues. I mean, we still get problems. And we still get, it's all using R8 still. But what, well, okay, because maybe, no, it's expression. Because I made this register num and then I never actually used it. So let's do that. Does that help? Oh, that was it. Yeah, see, that looks better. This is still a bit funky, but now these are different. Yeah, okay. I still do not like this code. We did all that work to optimize, and now I feel like we've de-optimized. And I do think we can sort of do a special case, you know, like if we know we're at the top level of an expression, then we don't need to do all this. This kind of keeping a reference to the stack pointer only helps if we're in a more complex expression where there could be allocations going on and things. But if we know we're at the top level, I think that's an easy way to say, like, hey, this is not necessary. I'm not going to do it right now because we're like an hour in. And we haven't even got to testing any expressions yet. But I think we've done pretty well and we've caught a few bugs. So already done pretty well. Actually, I think that was the end of the assignment stuff that I wanted to do. So we're a bit over an hour now, but let's just spend a bit of time doing some testing of expressions. And then I think that should be enough for now. I would also like to do procedure call testing, and I would like to do some testing of things that should not compile to verify that. But let's just do expressions for now. I think that's already a really good start. It already makes me feel a lot more confident about the language. If we can do all these combinations of things and they work. So, expressions. Let's start from booleans. So, true equals true. Boolean equal. Boolean not equal, so true does not equal false. Number So 1 equals 1, but 1 does not equal 2. Did I make things smaller? And yeah, I just want to differentiate because I'm going to put equal Boolean and not equal Boolean. I don't know what I'm doing. And then here we can just say like, I want to do like less than, greater than. So, and I guess we should test different cases here, right? Like there's kind of 3 cases. So it's like, less, equal, greater. So if it's less, if it's greater, and these should be false. They should fail. And for greater, we switch this around, and this one should be false, right? Cool. Oh, I wonder, since we fixed that other thing, did our main program fix? I sure hope so. Yes, good. Okay, less than, greater than. So then less than or equal. That's boom, boom, boom. And now that should also be true. And greater than or equal. And in this case, that should be true. Oh, and that needs to be equal, greater than or equal. Sweet. So that's all of our comparison operators. So now there's arithmetic operators. So we can do like 4 plus 2. And that's just add. Subtract. Multiply, divide. So that should equal 6. 4 plus 2 is 6. 4 minus 2 is 2. 4 times 2 is 8. 4 divided by 2 is 2. Oh my, invalid combination of opcode and operands. Line 845. Oh, look at all our strings. Huh. 845. I guess we can't divide by an immediate. Yeah, I have it open here actually. This is, and I like this cheat sheet because it tells me what you can use. So divide is actually a super, or actually it's idiv that we're using, but it's super complicated. It's like the result goes into AX, the divisor is in these 2 registers, and then what we're dividing by, and what we're dividing by is this. It needs to be a register or memory address. It cannot be an immediate. Otherwise it would have /im/imm there as well. So we can't use that number there directly. So I guess when we divide, here's the divide. So this is it. So I guess the right-hand side, we need to make sure it's, we'll put it in a register. So it could be register or immediate. So maybe we can make one like this. And this could probably apply to some other things that we've already done, actually. I'm surprising it's throwing such a hissy fit. I mean, maybe the procedure doesn't exist yet, but come on. If we could copy to non-immediate. So if it is a register or a memory address, we don't need to do anything. It's only if it's an immediate. And I feel like there are other situations where I just kind of, I guess because I didn't understand properly, I just always tried to get it into a register. So we could probably look at that. Just put a note here that we could be using this in some places, and then that could be a little more efficient. So if it's not an immediate, we just don't do anything. Otherwise, we do the copy. Source number size comment. Source number size. I think we can just use the result data size. For a divide, the result and the left-hand side should have the same size. And I guess we can also just use register. Well, now it failed the tests. So, oh, that should be RHS test. Yeah. Cool. And then I think maybe the last thing is that I want to do like a multiply and a divide. And I'm just doing it this way because I want the thing we divide by to be smaller than the, like we can't go to decimals. So I'm just putting the small thing on the right-hand side of the divide. So now we should have, so it's like add multiply, if I can spell multiply, and subtract divide. So that should be a subtract. So 4 times 2 is 8, plus 6 is 14. And 4 divided by 2 is 2. 6 minus 2 is 4. Nice. Now I want to add brackets. So we'll put this lower precedence thing in brackets so it happens first. So now we have 10 times 2, which is 20. And 2 divided by 2, which is 1. Cool. All right. Okay, I think we've done pretty well. We still need to do like procedure call stuff. I think the one other thing we can do is that negate. Let's put it right here. So 4 plus negative 2 should be 2. All right. So we've tested a lot of our expressions, declarations, assignments. I mean, obviously they're all fairly kind of simple cases. We don't have any really complex cases, you know, with like big crazy expressions. I think we should do something like that. Like we should do some procedure call testing, and then we should do some combinations of things, like maybe make a big expression that has some procedure calls and references some variables and has some numbers and then does a comparison so it converts to a Boolean and all of this stuff all in one massive expression to make sure it all gets handled correctly. And we need to do another. It's like a fight for the what do you call it? The optimized assembly. I do something in the right direction and then I take a step back and I go forwards again. Hopefully in the end the optimization part honestly it's something I enjoy doing, but it's not a huge priority. It's more important that it works and that it's reasonably clear. And I guess actually some of these issues that we're seeing were making it not very clear, you know? I feel like some of it was not very clear. I can't find the example now, but yeah, some things are a bit weird. But I think that was pretty good effort for today. We found a few bugs, right? We found one with vision. We found a big one to do with like the way that sort of left hands, like I guess variables were handled in general. And we kind of aligned that with the expression on the right hand side. I think there's a couple other things we found too. I think there was at least like 4 bugs we found and squashed. And made some good improvements. So I'm quite happy with that. I don't think we'll do more testing next time because I'm sure you guys don't want to watch me testing stuff like for video after video. So we'll do something more interesting next time. And maybe it'll just be a case of, you know, when I have a bit of extra time, I'll just throw in a few more tests as we go. And I'll try to test the new put tests for new features as we go also. Great. Okay. Thanks for stopping by. Have a good one. See you next time. All that stuff that I say. Ciao for now.